The last thing we're going to do in section 4.4 is an application problem. Let P of t be a population of the state of Utah in millions t years after 1970. In 1970, Utah had a population of about 1.06 million. Assuming a constant growth rate of 2%, the population of Utah satisfies the equation natural log P of t equals natural log 1.06 plus 0.02 times t. Find the population of Utah as a function of t. Calculate the population in 2018 using your function. Compare your calculation to the actual population in Utah in 2018, which is 3.16 million. All right, so we are going to start by making sure we just have a single logarithm on each side. To do that, this problem's a little more complicated than I expect you would need to know how to do. But see how we have a natural log on each side? What we're going to do is we're going to take the natural log. We're going to take both sides, with e being a base and this being the power. This is weird. This isn't something you would do in a lot of problems. Like I said, section 4.4 is probably not a huge deal. So if this stuff is not something you're understanding very well, don't worry. I'm thinking at this point we're going to move on to section 4.5 sooner than later, and this will kind of be just an enrichment optional thing. Don't know for sure. I've got to look at the homework problems and see what I think. So anyway, I'm taking both sides and raising them to the power of what's on each side. It's kind of the opposite of the one-to-one property. So the reason to do that is because these are inverses. So that cancels out and we end up with our function just p of t. And then here, if we have exponents that are adding, we can separate that into two separate exponentials that are multiplying instead of adding. We're using like that product property. Okay, so the cool thing about doing that is that we can cancel these out. So we're just left with 1.06 times e to this. So we have p of t equals 1.06 times e to the 0.02t power. We have created a function p of t, finding the population in terms of t. So now all we have to do is figure out how many years are between 2018 and the starting year for this function, which was 1970. I was born in 74, so the number of years here is a little bit more than I am old. So 2018 subtract 1970 is 48 years. So now I'm going to evaluate my function, p of 48 years, and all I have to do is put this in a calculator. You can find a scientific calculator, usually by turning a phone sideways, or Desmos, I'm pretty sure, has a calculator you can use, and just plug 48 into that calculator. Or you can use an approximate value for e instead of using a scientific calculator. You can use any calculator and just type in an approximate like 2.71. Okay, so we type that in a calculator and we get an approximate value of 2.768 million. So that means Utah is growing faster than this model predicted. I don't know the numbers for 2020. That would be interesting to try it, but we already know that this particular function is not on track to work 48 years later after it was figured out to be a good equation.